Picture this: a lone astronomer, sipping coffee in the dim glow of monitors, surrounded by the quiet hum of machinery at some ungodly hour of the night. The universe, as far as the data shows, is behaving exactly as expected until it isn't. Without warning, the speakers crackle to life with a sound that shouldn't exist, a pulse so precise, so unnervingly artificial. It sends a jolt down the spine of everyone in the room. This isn't static, this isn't a glitch, this is something listening back. That moment, the day deep space echoed a signal that defied all logic, wasn't just a fluke. It was a cosmic curveball that ripped through the foundations of astrophysics and left the brightest minds on Earth scrambling for answers. Where did it come from? Was it a natural phenomenon we've never witnessed before, or something far more extraordinary? The implications were staggering. If this signal wasn't born from any known star, black hole, or celestial event, then what or who could have sent it? This is the mystery we're diving into today, a trail of cosmic breadcrumbs that leads us to the edge of human understanding. We'll retrace the frantic hours after that signal hit, the theories that collapsed under scrutiny, and the chilling possibility that we're not alone in the universe after all. Buckle up, by the time we're done, you'll never look at the night sky the same way again. The year was 2023 when everything changed. It started as just another night at the observatory, another shift of scanning the cosmos for the usual hum of pulsars, the whisper of distant galaxies. Then, without warning, the monitors lit up with a pattern so bizarre, so unnervingly precise, that the astronomer on duty nearly dismissed it as equipment failure. But when the signal repeated not once, not twice, but in a rhythmic sequence that defied natural explanation, the reality set in. This wasn't random cosmic static. This was a message. What made this signal impossible to ignore was its fingerprint. Most deep space radio bursts are chaotic, fleeting like a scream vanishing into the void. But this, it pulsed in a loop, its frequencies aligning in a way no black hole or neutron star could produce. Even stranger, it came from a patch of space so empty, so devoid of known celestial bodies, that scientists initially questioned their own instruments. Yet telescope after telescope, from the high deserts of Chile to the frozen plains of Antarctica, locked onto the same impossible coordinates. The signal was real. And it was waiting. Then came the real shock. When researchers analyzed the transmission structure, they found layers almost like a language. Buried in the noise were mathematical constants, ratios so perfectly mirrored they couldn't be coincidence. It was as if the universe itself had written a riddle in radio waves. Was this a natural phenomenon we'd simply never encountered? Or was it the first faint echo of intelligence beyond our own? The debate tore through scientific circles, with theories ranging from colliding neutron stars to whisper it, something far more deliberate. One thing was certain: humanity had just stumbled onto a mystery that could rewrite the textbooks. And the clock was ticking to decode it before the signal vanished forever. Within hours of that first detection, the world's top scientific minds were in a state of controlled chaos. Emails flew between continents before the sun had even risen in some time zones, urgent requests for verification, hastily organized conference calls, observatories abruptly reshuffling their observation schedules. What normally would take months of peer review and debate was unfolding in real time, with pre-print research papers flooding servers faster than anyone could fact-check them. The signal didn't just challenge theories, it upended the entire scientific process overnight. At the heart of the frenzy were two warring camps. On one side, the skeptics, brilliant astrophysicists who'd spent careers studying cosmic anomalies. They argued this was likely some exotic natural phenomenon. perhaps a never-before-seen interaction between neutron stars, or a bizarre atmospheric distortion magnifying a mundane signal into something unrecognizable. Their mantra, extraordinary claims require extraordinary evidence, but across the aisle, a smaller, more daring group pointed to the signal's eerie precision. The way it repeated in clean intervals, the way its frequency bands aligned like the teeth of a cosmic key. Nature doesn't do symmetry like this, one SETI researcher famously tweeted, then quickly deleted. Meanwhile, something unprecedented was happening beyond academic circles. Government agencies normally silent on astronomical matters suddenly demanded briefings. Satellite networks quietly adjusted their orbits, as if preparing to triangulate something. And then came the leaks, grainy screenshots of classified reports, anonymous forum posts from alleged insiders claiming the signal wasn't just artificial, but targeted. The public reaction was instant and volcanic. Social media platforms erupted with theories ranging from plausible to outright apocalyptic. Late-night hosts joked about alien dinner invitations, while conspiracy forums dissected every frame of press conferences for hidden meanings. What made this different from past false alarms was the data itself. Unlike the infamous WOW signal of 1977, a one-off blip that vanished, this transmission lingered. It pulsed like a heartbeat for 72 straight hours before fading, only to return exactly 43 days later at the same coordinates. That kind of predictability wasn't just unusual, it felt intentional. Laboratories from Berlin to Tokyo began running the signal's waveform through every decryption algorithm they had, searching for hidden layers. One team even fed it into AI systems designed to detect linguistic patterns. The results were inconclusive but not entirely negative. As tensions mounted, an uncomfortable question hung over the scientific community. What if they weren't the first to notice it? Buried in old radio telescope archives, researchers began finding eerie matches, faint echoes of similar frequencies recorded decades earlier but dismissed as noise. Had this signal been transmitting for years, quietly waiting for someone to recognize it, the implications sent a shiver through even the most hardened skeptics. Because if that were true, it changed everything, not just about the signal, but about humanity's place in the cosmos. At first, scientists clung to the comforting notion that this signal, no matter how bizarre, had to be natural. The universe is vast, after all, and full of phenomena we don't yet understand. The leading theory, a new type of pulsar, one that behaved unlike any previously documented. Pulsars are cosmic lighthouses, spinning neutron stars that emit beams of radiation at staggeringly regular intervals. But this signal wasn't just regular, it was mathematical, its pulses aligning with ratios found in fundamental physics equations. No known stellar object could produce such precision. Then came the interstellar plasma theory. Perhaps, some argued, clouds of charged particles drifting between stars had distorted a mundane signal into something unrecognizable, like a cosmic game of telephone. But when researchers modeled the idea, the numbers refused to cooperate. Plasma interactions are messy, prone to scattering and distortion. This signal was clean, its structure intact across light years of travel. It was as if someone had engineered it to withstand the noise of the universe. The most daring natural explanation came from a small group of theorists who proposed cosmic strings, hypothetical, ultra-dense flaws in the fabric of spacetime left over from the Big Bang. If such strings existed, they might vibrate like guitar strings, producing exotic signatures. But even this fringe idea faltered. The signal's repeating pattern didn't match any predicted string vibration. Worse, cosmic strings should emit gravitational waves, something no detector had picked up. Then there was the black hole hypothesis. Maybe, scientists mused, the signal was an echo, a ripple of energy bouncing off the event horizon of some unseen, ancient black hole. But black holes don't echo in neat, repeating intervals. Their signatures are chaotic, warped by their immense gravity. This signal was disciplined, its timing as reliable as a Swiss watch. With each failed explanation, the unthinkable gained traction. If every natural cause crumbled under scrutiny, only one possibility remained: intelligence. Not the vague, hopeful maybe of past SETI dreams, but a signal so deliberate, so engineered, it seemed to mock humanity's attempts to explain it away. The implications were staggering. Either we'd discovered an entirely new class of astrophysical phenomenon, one that defied every known law, or we were no longer alone in the universe. And neither answer was comforting. For decades, the search for extraterrestrial intelligence operated on the fringes of mainstream science, a field of quiet optimism, fueled more by philosophy than hard evidence. But this signal changed everything when senior SETI researchers broke protocol to openly discuss an intelligent origin. It wasn't just cautious speculation. The numbers told a story too compelling to ignore. Embedded in those radio waves were ratios mirroring prime numbers, mathematical constants like pi, even the hydrogen line frequency, universal concepts any technological civilization would recognize. It wasn't just a signal, it was a language lesson. What sent chills down researchers' spines was the transmission's eerie convenience. The frequency landed squarely in Earth's atmospheric window, that narrow band where our planet's air is transparent to radio waves. Too precise to be chance, too convenient to ignore. It was as if someone had studied our atmosphere from light years away and chosen the perfect channel to say, "We know you're listening." Yet for all the excitement, doubt persisted. The universe is vast enough that improbable coincidences become inevitable. Could this be the ultimate cosmic prank, a quirk of physics masquerading as intelligence? To test the hypothesis, scientists turned to the ultimate litmus test: artificiality. Natural signals drift and decay. This one held its frequency with atomic clock precision. Natural signals vary in intensity. This one pulsed with metronome consistency. Most damning of all, when researchers scrambled telescopes across the globe to triangulate its source, the signal's origin point showed no hint of a star, nebula, or any known celestial object. It was broadcasting from nowhere, a patch of darkness where nothing should exist. Then came the bombshell. A team at the Allen Telescope Array noticed something everyone else had missed. The signal wasn't just repeating, it was evolving. Each transmission cycle introduced subtle variations, like chapters in a book. Some sequences resembled error-correcting codes used in human digital communications. Others defied explanation entirely, their patterns neither random nor algorithmic, but something in between. The most unsettling discovery, buried in the noise, were bursts of data that, when visualized, formed geometric shapes: perfect circles, nested triangles, even what looked like a three-dimensional cube. Skeptics scrambled for counterarguments. Maybe this was some bizarre form of interstellar scintillation, radio waves bent by invisible clouds of plasma into artificial-seeming patterns. But plasma distorts, it doesn't encode. Others suggested a secret military experiment, though no nation on Earth possessed technology capable of such sustained, high-powered transmissions from deep space. The simplest explanation, that we were hearing another civilization, remained the most terrifying, because if they were advanced enough to engineer a signal that survived millennia of interstellar travel, what else were they capable of? As the debate raged, a quiet realization settled over the scientific community. Proof wasn't the issue. The signal's artificiality was becoming undeniable. The real question was far more profound. Were we ready for what came next? Decoding the message might be trivial compared to grappling with its consequences. Every assumption about humanity's place in the cosmos hung in the balance, and the signal kept transmitting, patient as the stars themselves. History has a way of humbling our cosmic ambitions. Long before this mysterious signal crackled through the void, humanity had already weathered its share of false alarms, each one a lesson in caution. Take the infamous WOW signal of 1977, a 72-second radio burst so peculiar that the astronomer who discovered it scrawled "WOW" in red ink on the printout. For decades, it stood as the strongest candidate for an alien transmission until researchers traced its likely origin to a passing comet, its hydrogen cloud mimicking an artificial signal. Then came the Lorimer burst of 2007, a millisecond-long blast of energy that seemed to defy explanation until similar signals were linked to magnetars, the universe's most volatile stellar corpses. But this new signal refused to fit the old patterns. Where past anomalies flickered and vanished, this one endured. Where they were chaotic, this was precise. Most chilling of all, when researchers at the Green Bank telescope deliberately aimed a return transmission at its coordinates, a simple pulse containing prime numbers, the signal's next repetition included those same numbers, rearranged into a more complex sequence. It wasn't proof, but the timing was statistically improbable. As one astrobiologist put it, the universe doesn't play 20 questions. The deeper scientists dug, the stranger the parallels became. Historical signals like the WOW were one-offs, easily dismissed as glitches or natural phenomena. This transmission, though, seemed to learn. Early cycles were simple pulses, but later repetitions incorporated elements from Earth's own radio leakage, fragments of old television broadcasts, radar pings, even the faint echo of the Apollo moon missions. It was as if something out there was sifting through humanity's noisy radio history and reflecting it back, refined into something unrecognizable. Skeptics pointed to the long, painful history of human projection, how every unexplained signal inevitably gets draped in our hopes and fears. But the data told a different story. Previous false alarms lacked the hallmarks of true artificiality. Redundancy for error correction, layered information encoding, the kind of structured complexity that screams design. This signal had all three. Even its silence was suspect. Unlike natural phenomena that fade randomly, it disappeared at predictable intervals, as if conserving energy or waiting for a reply. Perhaps the most unsettling comparison lies in the timeline. The WOW signal was investigated for years before a plausible natural explanation emerged. This signal, by contrast, resisted every conventional theory within weeks. Laboratories from Berkeley to Moscow recreated its patterns using everything from plasma physics to quantum algorithms, and consistently hit dead ends. The only models that came close, those based on human communication protocols. Now, a new fear gnaws at the edges of the debate. What if past signals weren't all false alarms? Buried in old SETI archives are dozens of unexplained bursts, each dismissed as noise due to lack of repetition. But if this signal teaches us anything, it's that persistence is the ultimate litmus test. The cosmos might have been whispering all along, we just weren't listening long enough to hear the pattern. The moment the signal was confirmed as non-terrestrial, the corridors of power went silent in a way only governments can manage. Overnight, telescopes operated by military agencies were rerouted not toward the signal, but away from it, as if avoiding eye contact with something lurking in the dark. Emails between civilian researchers suddenly bounced back with cryptic error messages. Entire servers storing raw signal data were abruptly taken offline, replaced with vague statements about system maintenance. It wasn't just secrecy, it was a blackout. Then came the leaks. A systems engineer at a European space agency anonymously posted screenshots of an internal memo ordering staff to cease all further analysis of anomalous deep space transmissions pending review. The document carried no official letterhead, but the digital signatures matched high-ranking officials. Hours later, the post vanished, along with the user's entire online presence. Meanwhile, in Washington, journalists at two major outlets received near-identical tips. The signal's coordinates had been quietly added to a classified Pentagon database, usually reserved for nuclear missile trajectories and hostile satellite movements. The most damning revelation came from an astronomy PhD student in Chile. During a late-night observation shift, they'd accidentally intercepted an encrypted military transmission, a tense exchange between ground control and a reconnaissance satellite. One phrase stood out: confirmed secondary emission at bearing 009. The satellite in question wasn't pointed at Earth or its usual orbital threats. It was aimed directly at the signal's origin. Governments have never been good at keeping cosmic secrets. During the Cold War, both the US and Soviet Union monitored each other's space programs with paranoid intensity, yet neither interfered with civilian astronomers. This time was different. Observatories found their funding audits suddenly accelerated. Key researchers received unannounced visits from officials in unmarked cars. In one brazen case, a university's entire radio astronomy department was ordered to temporarily relocate so the building could undergo structural safety inspections, while men in tactical gear wheeled in classified equipment. The speculation spiraled from curious to catastrophic. Online forums dissected every scrap of information, with theories ranging from the plausible governments fearing mass panic to the apocalyptic. Some pointed to historical precedents. When the Pentagon's UFO report was declassified in 2021, it contained references to unknown aerial phenomena performing maneuvers that defied known physics. Was this signal another piece of that puzzle? Others whispered darker possibilities. What if the message wasn't a greeting but a warning, or worse, a beacon? Then a break in the silence. An aging radio astronomer, decades into retirement, gave an interview to a small science podcast. Speaking carefully, he recalled a similar signal detected in 1989 by a Soviet telescope in Kazakhstan. The data was shipped to Moscow overnight, and the team was reassigned. 2 months later, the telescope was dismantled for modernization. The astronomer's final words before the interview was abruptly cut from the podcast's feed. They've known this was coming. The question is, why are they scared now? When the news broke, it didn't just ripple, it detonated. Social media platforms became battlegrounds overnight, flooded with pixelated conspiracy charts, frantic prayer circles, and memes oscillating between hilarity and existential dread. One viral post superimposed the signal's frequency pattern over ancient Sumerian texts, proving it matched prophecies from 5,000 years ago. Another showed a grainy photo of a military hangar with the caption, "They've had the tech for decades, why do you think Elon's suddenly building rockets?" The line between satire and sincere belief evaporated. Religious institutions faced a crisis of cosmic proportions. Some denounced the signal as a test of faith, while others saw divinity in its mathematical purity. In Mumbai, crowds gathered at temples interpreting the pulse sequences as echoes of sacred mantras. At the Vatican, astronomers quietly consulted with theologians, revisiting centuries-old debates about extraterrestrial life and the soul. Meanwhile, street preachers from Seoul to Sao Paulo declared the signal the opening note of the apocalypse. their megaphones blaring over sidewalk astronomers who just wanted to share telescope views of the signal's origin point, a patch of sky now more scrutinized than any celebrity. Then came the private sector's gold rush. Tech moguls pivoted from Mars colonies to deep space communication arrays, racing to reply first, like billionaires vying for a viral tweet. One startup promised to encode Wikipedia into laser pulses, while another crowd funded a project to beam the entirety of TikTok into the void because if aliens were watching, why not give them the full human experience? The irony was palpable. Humanity's first contact might be sponsored by venture capital, but beneath the frenzy simmered a deeper unease. Polls showed a near-even split between those awed by the prospect of cosmic neighbors and those stockpiling supplies in basements. Psychologists coined the term signal stress to describe the insomnia and anxiety spikes reported worldwide. Late-night call-in shows fielded questions from parents terrified their children would grow up in a world where humanity was no longer special or safe. The signal had become a Rorschach test for the species, revealing more about our fears than the mysteries of deep space. Perhaps most telling was the silence where noise should have been. Governments issued vague statements about ongoing analysis, while intelligence agencies scrubbed their websites of unrelated UFO reports. In living rooms and labs alike, the same unspoken question lingered. If this was just the beginning, what came next? The signal kept transmitting, indifferent to the chaos it had unleashed. Humanity had spent centuries imagining first contact as a moment of unity. Instead, it held up a mirror, and the reflection was anything but united. Skeptics fought back with the grit of scientists trained to distrust miracles, their first line of defense, Earth itself. Could this signal be some classified military experiment gone rogue? A high-frequency radar test bouncing off the ionosphere in unexpected ways? The theory gained traction when researchers uncovered Cold War records of Soviet woodpecker signals that once disrupted global radio bands. But the math betrayed them. This signal's Doppler shift, the telltale stretch and squeeze of frequencies caused by relative motion, placed its origin far beyond Earth's gravity well. Whatever was broadcasting, it wasn't just outside our atmosphere, it was outside our solar system. Then came the software glitch hypothesis. With modern telescopes relying on labyrinthine code, could a bug have conjured this phantom signal? Teams at 3 separate observatories ran diagnostics for 72 straight hours, stripping their systems down to bare metal firmware. The signal persisted. Worse, it appeared in raw, unprocessed data streams, the kind that bypassed algorithmic filters entirely. Like a ghost appearing simultaneously on every security camera in a haunted house, it defied technological excuses. The most creative counterargument came from quantum physicists. Could quantum entanglement, that spooky action at a distance, have somehow teleported a human-made signal into deep space? The idea was seductive, until researchers realized the signal's light-year-scale journey would have required it to travel backward through time to match detection dates. Even Einstein's weirdest predictions had limits. With each debunked theory, the signal's defiance grew more profound. Its radio frequencies avoided the crowded bands where human-made noise clustered. Its timing synced with no known satellite orbits. Most damning of all, when astronomers tracked its position against the cosmic microwave background, the universe's oldest light, they found it originated from a region with no galaxy clusters, no dark matter halos, just the perfect void between superclusters. The perfect place to hide or to watch. By the time the last skeptic conceded, the argument had flipped entirely. The burden of proof now lay on those claiming it wasn't artificial. Because after months of scrutiny, one truth remained. The signal obeyed no natural law we understood, yet perfectly mimicked the hallmarks of intelligence. It was as if the universe had thrown a stone that ignored gravity, pierced walls, and landed gently in our hands with a note reading, "Catch me if you can." The real question wasn't whether we believed the impossible. It was whether the impossible had finally come looking for us. The signal structure wasn't just complex, it was architectural, as if someone had built a skyscraper out of pure mathematics and left it drifting in the void. When researchers first mapped its pulse intervals onto a graph, the lines formed a perfect Fibonacci spiral, the same sequence found in sunflower seeds and hurricane patterns. Prime numbers marched through its frequencies like sentinels, their spacing too deliberate to dismiss as cosmic static. But here's where it got strange. These weren't just abstract numbers plucked from a textbook. They were encoded layered with geometric ratios that mirrored the orbital periods of our own solar system's planets. It was as if the signal was holding up a mirror to humanity's earliest astronomical discoveries and saying, "We see what you see." Then came the binary. Or at least what looked like binary. Sections of the transmission aligned neatly into ones and zeros, but when cryptologists ran it through every decryption protocol from military-grade ciphers to ancient linguistic algorithms, the results made no sense. Some sequences resembled error-correcting codes used in modern computing, while others echoed the repetitive structure of DNA base pairs. One team at Stanford even found a segment that, when converted into a three-dimensional spectrogram, displayed a perfect icosahedron, a 20-sided shape found in everything from viruses to quantum geometry. The universe doesn't do accidental icosahedrons, but the real enigma lay in what didn't compute. Between these crystalline structures were bursts of noise that defied all categorization, not random but not algorithmic either. When played as audio, they produced chords that no human instrument could replicate, hovering between musical notes in a way that prickled the hairs on musicians' necks. Visualized as light, they generated color gradients outside the visible spectrum. Leading cryptologists describe the experience of analyzing it as trying to read a book where every other page is written in a language that doesn't exist yet. The most chilling realization, the signal wasn't static. Early transmissions had been simple, almost conversational. But as weeks passed, its complexity grew exponentially, as if responding to humanity's attempts to understand it. When radio telescopes in Australia beamed a sequence of prime numbers toward its origin point, the next transmission cycle included those same primes, but rearranged into a fractal pattern that solved a quantum math problem researchers had published just months earlier. The implication was staggering. Either this signal was scanning our scientific journals in real time, or it already knew what we'd discover before we did. Now the debate rages on. Is this a message patiently waiting for us to develop the tools to comprehend it? A beacon marking some interstellar crossroads? Or something far more unsettling, not a transmission at all, but a presence, using radio waves the way a sculptor uses clay? Every breakthrough in understanding seems to open three new questions. And the signal keeps transmitting, its structure evolving, its origins as inscrutable as the moment it first pierced the silence of the deep. Astrobiologists found themselves staring down a paradox wrapped in static. If this signal was indeed artificial, its origin point, a seemingly empty patch of space thousands of light-years away, defied every expectation. Exoplanet surveys had long mapped our galactic neighborhood, cataloging thousands of stars within 100 light-years. None showed signs of civilization, yet here was a transmission so powerful, so deliberate, it could only come from a society wielding technology beyond our wildest models. The implications were staggering. Either we'd missed something fundamental about how civilizations rise and fall, or the universe had just handed us a riddle that rewrote the rules. The Fermi paradox suddenly felt less like an abstract thought experiment and more like a countdown clock. Where was everybody? For decades, scientists had assumed that if advanced civilizations existed, their signatures, radio leakage, megastructures, even interstellar probes would be obvious. This signal flipped that assumption on its head. It wasn't just a whisper lost in cosmic noise. It was a shout engineered to pierce the void with surgical precision. And that raised an unsettling possibility. What if other civilizations were out there but deliberately silent until now? Then came the distance problem. Based on the signal's redshift, its source lay somewhere in the distant halo of our galaxy, far from the star-rich spiral arms where life was thought most likely to emerge. The energy required to beam a message across such a gulf was incomprehensible, equivalent to harnessing the output of 1,000 suns. No known natural process could focus that much power into a coherent signal. Yet the alternative was equally jarring. A civilization so advanced, it treated interstellar communication like we treat texting. This forced a reckoning with the Great Filter hypothesis, the idea that some catastrophic barrier prevents civilizations from reaching interstellar maturity. Had the senders of this signal slipped past it, or were we witnessing their final, desperate broadcast before succumbing to whatever cosmic hurdle lay ahead? The timing was suspiciously convenient. Humanity had just begun leaking radio waves into space a century ago, a blink in cosmic terms. For another civilization to detect those faint signals, calculate our position, and craft a reply within such a narrow window strained belief. Unless, of course, they'd been listening far longer than we'd been transmitting. Perhaps the most haunting question wasn't about the signal's origin, but its longevity. Civilizations rise and fall, stars burn out. For a message to endure thousands of years of interstellar travel, its creators would need near immortality, either as a species or as machines. Some researchers speculated about post-biological intelligence, civilizations that had uploaded their minds into indestructible quantum substrates, patiently threading messages through the galaxy like cosmic lighthouses. Others feared darker scenarios. What if this wasn't a greeting but a relic, the last gasp of a long-dead empire, its automated beacons still chirping into the void long after their makers turned to dust? The signal's very existence tugged at the foundations of astrobiology. Maybe life wasn't rare, just fleeting. Or perhaps intelligence inevitably evolves into something unrecognizable, its signals so advanced we mistake them for natural phenomena. One thing was certain, the universe had just handed us a puzzle where every possible answer led to more questions. And somewhere in the dark, the signal kept repeating, indifferent to whether we were ready for the truth. Here we were, armed with the most advanced radio telescopes ever built, arrays that could detect the faintest whisper of a dying star halfway across the galaxy, and yet we couldn't even get a clear fix on where this signal was coming from. The best estimates placed its origin somewhere within a volume of space spanning thousands of cubic light years, a cosmic haystack with no obvious needle. Every time a team thought they'd narrowed it down, the data would shift like smoke, defying precise triangulation. It wasn't just a technical hurdle, it felt like a taunt. The scramble to upgrade our tools was frantic. Blueprints for next-generation arrays, projects once penciled in for decades down the line, were pulled from drawers and rushed into funding hearings. Engineers proposed repurposing entire satellite networks into makeshift deep space ears. One audacious plan involved turning the moon's far side into a natural radio dish, shielded from Earth's noise. But even the most optimistic projections admitted the truth. We were playing catch-up with a rival who'd lapped us before we even knew the race had started. The signal's sheer clarity was the real gut punch. Interstellar space is messy, packed with plasma clouds, magnetic fields, and gravitational lensing that distort and scatter radio waves like a funhouse mirror. Yet this transmission arrived crisp as a studio recording, its structure untouched by millennia of travel. That level of precision implied technologies we couldn't even conceptualize, transmitters powerful enough to punch through cosmic interference without breaking stride, or perhaps something even stranger, like engineered space-time corridors that kept the signal pristine. Either way, the message was clear. Whoever sent this wasn't just advanced. They operated on a scale that made our entire civilization feel like cave painters staring at a smartphone. Then came the chilling realization about energy. Broadcasting across such distances should have required power outputs dwarfing our sun's total output, an unthinkable expenditure by any human standard. Yet the signal's efficiency suggested otherwise. Its carrier waves were so finely tuned, so devoid of waste, they hinted at energy mastery beyond fusion or antimatter. Theories ricocheted through physics forums: zero-point energy harvesters, black hole batteries. The math pointed to a civilization that had cracked the universe's cheat codes, bending thermodynamics to their will. For the first time, humanity faced a hard truth about our place in the cosmos. We'd spent centuries marveling at our own ingenuity. Split atoms, spliced genes, touched the edge of the solar system. But this signal was a mirror reflecting back something humbling. However grand our achievements felt, we might not even rank as apprentices in the galactic workshop. The real question wasn't whether we could build a telescope big enough to locate the source. It was whether we'd recognize the answers if they stared us in the face. The signal didn't just crackle through our telescopes, it tore through the foundations of human identity like a cosmic lightning strike. Overnight, centuries of religious doctrine faced their most profound challenge since Galileo. The Vatican's astronomers worked feverishly to reconcile the discovery with scripture, while Buddhist scholars debated whether enlightenment could extend beyond Earth. Evangelical megachurches split into factions, some declaring the signal a test of faith, others branding it the ultimate deception. In Tehran and Jerusalem, theologians pored over ancient texts, searching for prophecies that might now read less like metaphor and more like operating manuals. The question wasn't whether God existed, but whether he or they had been speaking to other civilizations all along. Philosophers found themselves in uncharted territory. The great Enlightenment thinkers had wrestled with humanity's place in nature, but none had imagined we might one day answer to minds beyond it. Ethics departments from Oxford to Kyoto convened emergency seminars to debate a new branch of philosophy, xenomorality. If another intelligence had engineered this signal, did its creators operate on principles we could even comprehend? Kant's categorical imperative suddenly seemed provincial when applied to beings who might perceive time, individuality, and causality in ways our brains couldn't model. The most unsettling realization: for the first time in history, humanity wasn't just debating abstract ideas. We were potentially being observed by the very intelligences we theorized about. Art became the world's collective nervous system, vibrating with interpretations. Digital artists rendered the signal as pulsing neon mandalas, while underground musicians fed its frequencies into synthesizers, creating soundscapes that hovered between music and mathematics. Novelists who'd spent careers writing about first contact now faced the absurdity of fiction becoming homework. One viral webcomic depicted the signal as a cosmic read receipt on humanity's earliest radio broadcasts with the caption, "They've seen our episodes. They're just waiting to see if the series improves." But beneath the creative explosion lurked a primal unease. Psychologists reported a surge in cosmic displacement anxiety. patience overwhelmed by the sense that humanity might be mid-tier in a galactic hierarchy we'd never even detected. Survivalists stockpiled supplies not for economic collapse but for what they called the intellectual singularity, the moment an alien curriculum rendered human knowledge obsolete. Conspiracy forums bubbled with dark fantasies. What if the signal wasn't a message, but a diagnostic scan? A predator testing Earth's defenses? The most chilling artworks weren't the apocalyptic ones, but those that portrayed the signal as indifferent. A single note in a symphony so vast, our entire civilization registered as barely a vibration. Yet in this chaos emerged something unexpected: fragile threads of unity. Astronomers in traditionally adversarial nations began sharing data in real time, bypassing bureaucratic red tape. A grassroots movement called One Reply petitioned the UN to formulate a collective response rather than letting powerful nations speak for the species. Even the skeptics and believers found common ground in one humbling truth: the signal had reduced humanity's grandest achievements and bitterest conflicts to a single blinking dot on someone else's, or something else's cosmic dashboard. We weren't just discovering life beyond Earth, we were discovering how small that discovery made us feel. For the first time in history, the world's superpowers did something extraordinary. They put down their weapons, both literal and diplomatic, and turned their eyes upward together. The United Nations Security Council, typically gridlocked by vetoes, unanimously greenlit the formation of an unprecedented task force, the Deep Space Signal Coordination Group. Overnight, data silos between NASA, Roscosmos, the European Space Agency, and even traditionally isolated programs like China's National Space Administration crumbled. Telescopes from the Atacama Desert to the Tibetan Plateau synchronized their observations, while supercomputers in Geneva, Cape Town, and Tokyo ran joint simulations around the clock. It was as if the signal had flipped a switch in humanity's collective psyche. For a fleeting moment, we weren't rival nations. We were a species with a shared question hanging over us. But unity, as it turns out, has an expiration date. Behind closed doors, the old tensions resurfaced in new disguises. The task force's first major fight wasn't about astrophysics, it was about linguistics. When the group debated sending a reply, the US pushed for a message rooted in mathematics and physics, arguing these were universal languages. Russia countered with a proposal to include cultural artifacts, folk music, poetry, claiming intelligence wasn't just about equations. Meanwhile, India's delegation quietly pointed out that all the drafted messages used Latin alphabets and Western musical scales, asking, who decides what universal really means? The room fell silent. For all our talk of speaking for Earth, we hadn't even agreed on how to speak to one another. The classification wars were worse. While civilian scientists celebrated open data sharing, intelligence agencies engaged in a shadow game of obfuscation. Leaked documents revealed certain nations had quietly filtered the signal's raw data through military decryption systems before releasing sanitized versions to the global team. One NSA whistleblower later confessed their team had found anomalous sub-pulses in the original transmission, tiny, staccato bursts that never made it into the public datasets. When confronted, officials claimed it was just noise, but the damage was done. Trust, that fragile commodity, began eroding faster than it had formed. Then came the billion-dollar question: who gets to press send? The discovery had been collaborative, but transmission rights became a geopolitical minefield. Smaller nations, led by South Africa and Singapore, argued replies should require a UN majority vote. The nuclear-armed states disagreed. At one heated session, a French diplomat reportedly snapped, "Democracy is precious, but indecision could be catastrophic." If this is contact, we cannot wait for consensus while aliens grow impatient. The subtext was clear: when history knocks, power brokers don't line up. They kicked down the door. Beneath the bureaucratic skirmishes lay a deeper existential dilemma. Every draft reply felt tragically human, packed with our assumptions, our biases, our limited grasp of a universe suddenly seeming much stranger. One team of anthropologists grimly noted that all our proposed messages followed the same pattern. Here's what we know, here's who we are, please respond. It was the cosmic equivalent of a cold call. What if the signal wasn't an invitation to chat, but a warning to stay quiet? Or worse, what if we were already part of a conversation that started millennia ago, and we'd just missed the first 100,000 pages? The irony was palpable. After centuries dreaming of cosmic companionship, humanity stood on the precipice of contact only to realize we'd forgotten how to introduce ourselves. The signal kept pulsing, patient as a tide, while below, nations scrambled to agree on whether to whisper back or stay silent forever. The moment we confirmed the signal's artificial origin, an old warning echoed through the scientific community like a klaxon. Stephen Hawking's voice, though gone, seemed to whisper from every lecture hall and conference room. If aliens visit us, the outcome could be much like when Columbus landed in America, which didn't turn out well for the Native Americans. His caution wasn't paranoia, it was cold, hard game theory. The universe operates on scales of time and power we can barely fathom. What if we weren't initiating a conversation, but ringing a dinner bell? Yet the counterarguments burned just as bright. For centuries, humanity had dreamed of this moment, proof we weren't shouting into an empty cosmos. To stay silent now felt like cowering in our own attic while the doorbell rang. Astronomer Jill Tarter, a legend in SETI research, framed it differently. Fear is not a strategy. If every civilization chose silence, the universe would be a library where no one dares to speak. Her point cut deep. The signal's very existence suggested someone out there had overcome this same fear. What if they'd been waiting millennia for an answer? The debate split along ideological fault lines. Security hawks saw first contact through the lens of human history. Every encounter between advanced and less advanced civilizations had ended in exploitation. Silicon Valley futurists countered with Moore's law logic. Any civilization capable of interstellar communication would view us as ants view bacteria, too insignificant to conquer. Ethicists raised darker questions. Even if the senders meant no harm, what if their mere existence triggered Earth's collapse? Religions fracturing, economies seizing, governments toppling under the weight of cosmic insignificance. Was it ethical to risk global stability for knowledge? Then came the pragmatists with a brutal truth: it might not matter. Our planet had been leaking radio waves since the 1930s, sitcoms, radar pings, presidential speeches, all drifting outward at light speed. If the signal's senders had heard our noise, they already knew where we were. A reply wouldn't reveal our location, it would reveal our intent. That distinction haunted military strategists. Silence could signal weakness, engagement might show respect. There was no protocol, no precedent, just a species staring at a cosmic coin toss. Meanwhile, an uncomfortable realization took root. The signal had already altered humanity's trajectory, with or without a reply. Schools added xenolinguistics to curricula. The stock market birthed an entire sector for exoeconomics. Churches redesigned stained glass windows to include non-human figures. We weren't just debating whether to speak, we were realizing the mere possibility of listeners had changed how we saw ourselves. The genie wasn't just out of the bottle, it had rearranged the furniture. Now the question loomed larger than any one risk assessment. This wasn't about aliens. It was about what kind of civilization we chose to be. The the fearful ones who huddled in the dark, or the curious, reckless, hopeful species that couldn't resist answering when the universe finally whispered back. The signal pulsed on, indifferent to our crisis of conscience, and with each passing day, the weight of its silence grew heavier than any words we might send. The silence hit like a punch to the chest. One moment, the signal pulsed with metronome precision, each transmission arriving right on schedule, as predictable as sunrise. Then, without fanfare or distortion, it vanished, not a flicker, not a whisper, just dead air where cosmic certainty had been. Observatory control rooms worldwide froze in collective disbelief. Technics scrambled to check equipment, rerun diagnostics, convinced this had to be an error, but the truth was undeniable. After 73 consecutive cycles, the universe had hung up on us. What made the sudden absence so chilling was its clinical precision. Natural cosmic phenomena don't just stop, they decay, they sputter. A dying star collapses inward, a black hole's jets flicker like a candle in wind. This was like someone flipping a switch. The signal's final transmission showed no signs of weakening, no telltale scattering of frequencies, no Doppler drift suggesting its source was moving away. It was as if the sender had simply finished speaking. Theories erupted like synaptic sparks. Had the signal been a timed broadcast, repeating until some unseen clock ran out? Was its disappearance proof of intelligence, a deliberate endpoint to prevent endless loops? Or had something intervened? Conspiracy forums lit up with dark speculation. Perhaps we'd been deemed unworthy. Perhaps our attempts to decode the message had triggered some cosmic fail-safe. More sober minds pointed to the signal's 43-day reappearance cycle. If history held, the silence wasn't permanent, just another phase in a pattern we barely understood. Then came the unsettling data from the Allen array. Buried in the final milliseconds of the last transmission was an anomaly, a burst of compressed data unlike anything in prior cycles. When visualized, it resolved into a stark, singular image, a perfect circle bisected by a straight line. To mathematicians, it screamed pi. To cryptologists, it evoked a door closing. To the astronomers who'd spent sleepless months tracking every pulse, it felt like a punctuation mark at the end of a sentence humanity had only just begun to read. Now, the world faced a new kind of tension, not the frantic energy of discovery, but the agonizing weight of absence. Every radio dish on Earth stood trained on those empty coordinates, straining to hear a whisper that might never come. The signal had rewritten the rules of engagement, proving intelligence could exist beyond our planet. Its silence posed an even greater question: had it ever been meant for us at all? When the signal vanished, it didn't just leave silence, it left a void, and nature abhors a vacuum. Within hours, conspiracy theories rushed in like floodwaters, each more elaborate than the last. One faction, armed with grainy satellite images and leaked Pentagon slides, became convinced the signal had been a government psyop all along, an orchestrated crisis to justify space militarization. Think about it, argued a viral thread viewed millions of times. They shut it down the moment independent researchers got too close. Coincidence? Never mind that no earthly technology could mimic the signal's interstellar origin or its mathematical precision. For believers, absence of proof became proof of conspiracy. Then came the doomsday prophets. Certain fringe forums lit up with claims that the signal's disappearance wasn't an endpoint, but a countdown. Its 43-day cycle hadn't been a transmission schedule. They insisted it was a timer. Screenshots of the final burst's bisected circles spread like wildfire. It's a warning symbol. A cosmic check engine light. They've marked us, and now they're coming. The more outlandish variations spun tales of ancient alien prophecies hidden in Sumerian tablets or Navajo star lore, all supposedly predicting this exact moment. Never mind that human history is littered with enough vague prophecies to retroactively fit any anomaly. Pattern-seeking brains will always find shapes in the static. But the prize for creativity went to the time travel camp, a subset of theorists blending bad physics with creative storytelling claimed the signal wasn't extraterrestrial at all. It was a beacon from humanity's distant future. Why else would it mirror our math so perfectly? Argued a trending video essay. It's a bootstrap paradox. Our descendants are trying to guide us towards some pivotal breakthrough, but the timeline's too fragile for direct contact. The theory's elegance was its unfalsifiability. Every failed decryption attempt, every unanswered question, could be framed as intentional obfuscation to avoid paradox. Meanwhile, academic circles watched the frenzy with a mix of amusement and dread. This wasn't just harmless speculation, it was a case study in how quickly disinformation could eclipse reality. The same social media algorithms that pushed flat Earth memes now amplified cosmic doomsayers, their click-driven outrage loops drowning out sober analysis. Researchers who'd spent careers studying the signal found themselves debating TikTokers who'd never used a telescope. One astronomer tweeted, then deleted, the bitter truth: "We spent months chasing the universe's secrets. Now we're chasing our own tails." Yet beneath the noise lay a deeper truth. The signal had exposed humanity's Achilles heel, our inability to sit with uncertainty. Faced with the unknown, we'll spin stories, stitch together narratives, even embrace the absurd rather than admit we don't have answers. Maybe that's the real message the signal left behind. Not in its pulses or its patterns, but in the mirror it held up to a species desperate to hear whispers in the dark, even if we had to invent them ourselves. Science textbooks used to dedicate maybe a paragraph to the search for extraterrestrial intelligence, a footnote in the grand narrative of cosmic exploration. That changed overnight. The signal didn't just rewrite a chapter, it tore up the entire curriculum. Universities scrambled to design new courses blending astrophysics with xenolinguistics, while graduate students abandoned decades-old research projects to chase this single, electrifying mystery. One professor at Caltech famously told her class, "Forget everything you know about radio astronomy, we're starting from scratch." Funding portals swung open like airlocks in a sci-fi movie. Governments that once dismissed SETI as fringe science suddenly tripled its budget, with private donors racing to outpace them. The Breakthrough Listen project received an anonymous $500 million endowment within weeks of the signal's discovery, enough to build 3 next-generation telescope arrays. Even NASA, traditionally laser-focused on planetary exploration, reallocated probes to scan the signal's origin region for Dyson spheres or other megastructures. The message was clear: astrophysics had a new North Star, but the real revolution happened in labs and lecture halls. A generation of scientists who'd grown up on Star Trek now had tangible data to dissect, an actual artifact of potential intelligence. Doctoral candidates who might have spent careers modeling supernova instead devoted themselves to cracking the signal's layered patterns. Some focused on its mathematical constants, searching for hidden equations. Others analyzed its timing gaps, convinced the silences between pulses held meaning. A rebellious faction at MIT even fed the transmission into quantum computers, theorizing its true structure might exist in higher dimensions. The signal's greatest impact wasn't the answers it provided, but the questions it unleashed. Suddenly, respected journals published papers on topics that would have been laughed off a year earlier. Could information be encoded in the spin of electrons? Was the universe itself a kind of network, with these transmissions as its packets? Even the skeptics found themselves playing catch-up, forced to invent entirely new astrophysical phenomena to explain what they'd witnessed. Yet beneath the frenzy lay a quiet irony. For all our new tools and theories, the signal remained stubbornly inscrutable, a cosmic koan designed to humble as much as enlighten. Its legacy wasn't just in the telescopes we built or the equations we derived, but in the way it reshaped our collective imagination. The universe we now knew was capable of surprises far beyond our models. And somewhere in the dark, whether silent or still listening, the signal senders had achieved something extraordinary. They'd made Earth feel small again, not in the crushing sense of insignificance, but in the thrilling, childlike way of realizing how much was left to discover. Years have slipped by since the signal vanished into cosmic silence, but the search hasn't stopped, not even close. Observatory schedules still block off precious telescope time to stare at that empty patch of sky, night after night, like sailors scanning the horizon for a lighthouse that may never reignite. The difference now, we're not just waiting. We're armed with tools that didn't exist when the signal first crackled through the void. Machine learning algorithms, trained on every byte of the original transmission, now sift through decades of radio telescope archives, not just hunting for echoes of that first signal, but for anomalies we might have missed in our initial frenzy. It's digital archaeology combing through static for whispers of a conversation we barely began. The obsession isn't just sentimental. A stubborn cadre of researchers, many of them young grad students who'd barely started high school when the signal first appeared, are convinced its disappearance was never an ending. Their working theory, the signal wasn't a one-off broadcast, but part of a longer cycle, a cosmic check-in spaced across centuries, or even millennia. They point to faint, debated anomalies in 19th century star logs and medieval astronomers' notes about wandering lights that defied explanation. Could those have been earlier transmissions, dismissed as superstition? The idea borders on heresy in mainstream astronomy, but the believers press on, refining detection models to account for drift in interstellar mediums or shifts in Earth's own rotational wobble over centuries. Meanwhile, the tech has evolved in ways that would have seemed like magic back in 2023. Quantum computing clusters now run real-time decryption attempts on the original signal's most cryptic segments, testing for higher dimensional patterns. New arrays like the Lunar Far Side Radio Telescope, shielded from Earth's radio noise by 2,000 miles of moon rock, listen with unprecedented clarity. And then there's the radical fringe, experiments beaming synthesized versions of the signal's mathematical core into lab-created wormhole analogs, just to see if spacetime itself might hold clues about how something so precise could traverse light years unscathed. But the quietest revolution is in how we're preparing for the signal's return, because this time we won't be caught off guard. The International Academy of Xenocommunication, founded 3 years post-signal, has drafted protocols for everything from linguistic analysis to crisis diplomacy. Their first contact playbook isn't shelved in some vault. It's a living document, updated monthly with input from astrophysicists, AI ethicists, and even poets, because if the universe speaks again, we'll need more than equations to reply. For now, the night shift at every major observatory still includes someone staring at that stubbornly blank sector of sky, coffee in hand, monitors glowing. The joke among them is dark but persistent. We're either the generation that heard the universe say hello or the one that heard it say goodbye. Yet beneath the gallows humor lies a truth as vast as the silence itself. The signal didn't just change how we listen to the cosmos. It changed how we listen to ourselves, to the stories we tell in the dark, waiting for an echo that may never come. Amid all the theories of extraterrestrial intelligence and undiscovered astrophysical phenomena, a radical idea began gaining traction in certain academic circles, one so outlandish it made alien civilizations seem mundane by comparison. What if the signal wasn't coming from anywhere in our universe at all? A small but vocal group of theoretical physicists proposed an explanation that sounded ripped from the pages of sci-fi. The signal might be a cosmic echo bleeding through from a higher dimension or even a parallel universe. The math, at least, wasn't pure fantasy. String theory had long suggested the existence of extra dimensions beyond the four we experience: tiny, curled-up layers of reality woven into the fabric of space-time. Normally, these dimensions are imperceptible, but under extreme conditions like near a black hole or during the birth of the universe, they might vibrate in ways that leave detectable traces. The signal's bizarre properties fit uncomfortably well with this idea. Its unnatural precision, its resistance to cosmic interference, even its apparent ability to learn from our transmissions, all could theoretically be explained if it wasn't traveling through our universe at all, but around it, leaking through dimensional folds like sound through a wall. Then there's the multiverse angle. If inflationary cosmology is correct, our universe might be one bubble in an endless froth of others, each with different physical laws. Under rare conditions, these bubbles could brush against one another, exchanging energy or information at the boundaries. The signal's origin point, a void devoid of any known celestial objects, took on new significance in this light. Maybe it wasn't empty. Maybe it was a seam, a place where realities briefly touched. Skeptics, unsurprisingly, tore the idea to shreds. Without a mechanism to test higher dimensional leakage or observe parallel universes, the theory was about as scientific as guessing the contents of a locked box. But the physicists pushing the idea countered with a humbling truth. Every major breakthrough in cosmology was once considered ludicrous. Black holes, dark matter, the Big Bang, all were dismissed as mathematical fantasies before evidence forced them into textbooks. The signal, they argued, might be our first tangible hint that reality is far stranger than our three-dimensional intuition allows. What made the hypothesis linger wasn't its plausibility, but its audacity. In trying to explain the signal, we'd exhausted every conventional framework. Maybe the answer wasn't just unknown, maybe it was unknowable within our current understanding of physics. The universe had thrown us a curveball, and all our bats were too short to hit it. Whether the signal came from aliens, higher dimensions, or something beyond our imagination, one lesson rang clear: we weren't just hunting for answers. We were learning how vast the questions could be. Long after the signal faded from scientific headlines, it found new life in the collective imagination, transforming from an astrophysical anomaly into something far more potent, a cultural icon. Almost overnight, the mystery seeped into every creative medium imaginable. Blockbuster films reimagined it as everything from a cosmic distress call to an ancient alien alarm clock, their trailers teasing audiences with distorted radio static and cryptic star maps. Indie filmmakers took a quieter approach, crafting intimate dramas about lonely astronomers who'd sacrificed marriages, sanity, and even faith chasing whispers in the void. The signal became more than science. It became a mirror for our deepest hopes and fears about what might lie beyond Earth. Novelists pounced on the unanswered questions with glee. Best-selling sci-fi authors spun elaborate sagas where the signal's patterns were blueprints for forgotten technologies or fragments of an interstellar war. Literary fiction used it as a metaphor for miscommunication in human relationships, how even with infinite ways to connect, we still struggle to truly understand one another. One Pulitzer-winning novel reimagined the transmission as a love letter from a dying civilization, its mathematical constants forming stanzas in a trillion-year-old poem. Meanwhile, horror writers had a field day with the silence that followed, crafting tales where the signal's disappearance wasn't an endpoint, but the first ominous note in a countdown to catastrophe. Then came the podcasts. A serialized audio drama called Static became a global phenomenon, blending real audio clips from the signal with fictional detective work. Its creators hired actual radio astronomers as consultants, weaving genuine science into a narrative so gripping, universities reported surges in astrophysics applications. True crime podcasts pivoted to True Cosmos Mysteries, dissecting the signal's timeline with the same obsessive detail usually reserved for cold cases. Even late-night comedians couldn't resist one iconic monologue: imagined aliens tuning into Earth's reply only to get stuck in a customer service voicemail loop. But beyond the entertainment value, something more profound took root. The signal evolved into cultural shorthand, a way to talk about humanity's oldest questions without saying them aloud. Memes juxtaposed its pulsing waveform with texts like, "When you text we need to talk," and they reply K. Protest signs invoked it as a symbol of unity. If the universe can reach across light years, why can't we bridge a city block? Advertising campaigns hijacked its imagery to sell everything from smartphones to spiritual retreats, twisting its mystery into a sales pitch about connection. Perhaps the most telling adaptation came from an unexpected corner: modern art. Galleries from Berlin to Tokyo hosted exhibitions where the signal's data became immersive installations, walls pulsing with its converted light patterns, sculptures shaped like its fractal sequences, even a controversial piece where visitors could reply by screaming into a microphone that fed their voice into a star map. Critics debated whether this was profound commentary on cosmic loneliness or just pretentious gimmickry, but the crowds kept coming, drawn less to the art than to the ritual of standing shoulder to shoulder with strangers, all staring at the same inscrutable patterns, all quietly wondering the same thing. The signal's greatest legacy might be this: it turned existential dread into a shared experience. For centuries, staring at the stars was a solitary act: a philosopher on a hilltop, a sailor on night watch, a kid with a backyard telescope. Now, thanks to 72 hours of inexplicable static, the cosmos felt personal in a way no textbook ever managed. Whether it was aliens, glitches, or something beyond our comprehension didn't matter as much as the simple fact that for one brief moment the universe had whispered, and the entire species had leaned in to listen. The signal didn't just crackle through our telescopes, it shattered the illusion that humanity had the universe figured out. For centuries, we'd built towering theories, confident that with enough data and computing power, we could model everything from the birth of stars to the spin of electrons. Then came those 72 hours of perfect, pulsing static, a cosmic slap on the wrist reminding us how much we didn't know. The greatest minds in astrophysics stood baffled, their textbooks suddenly outdated, their equations useless. It was the ultimate humility check. The universe reserves the right to surprise us. What made this so unsettling wasn't just the signal's existence, but its indifference to our understanding. Natural phenomena usually play by rules. Gravity bends light predictably. Black holes emit Hawking radiation at calculable rates. But this was a wild card, a transmission that followed no known laws yet carried the unmistakable fingerprints of design. Scientists found themselves in the bizarre position of debating whether the signal was too precise to be natural or too advanced to be artificial. The very tools we'd used to decode quasars and dark matter crumpled in its presence. One researcher compared it to a medieval scribe encountering a smartphone. The object's purpose was obvious, but its workings might as well have been magic. Yet within that humility came an unexpected gift, a renaissance of raw curiosity. Suddenly, it was acceptable to voice heretical ideas in peer-reviewed journals. Papers on dimensional leakage, non-carbon-based intelligence, even time retrocausal signaling the notion that future events could influence past transmissions circulated without immediate ridicule. The signal had blown open the Overton window of astrophysics, proving that the most exciting discoveries often lie just beyond the edge of our current paradigms. Young grad students, less burdened by dogma, began revisiting abandoned theories with fresh eyes, asking, "What if we've been missing something fundamental?" The episode also exposed science's dirty little secret. We're terrible at predicting revolutions. Most major breakthroughs, relativity, quantum mechanics, plate tectonics, were initially dismissed as nonsense because they didn't fit existing frameworks. The signal forced institutions to confront their own rigidity. Funding agencies that once demanded 5-year research roadmaps now embraced high-risk, high-reward proposals. A new generation of telescopes was designed not just to confirm what we expected, but to detect what we couldn't imagine. The lesson was clear: prepare for surprises, because the universe owes us no explanations. Perhaps the most profound shift was in how scientists framed their work. Pre-signal, conferences were dominated by incremental findings, tiny adjustments to cosmological constants, slight refinements to particle physics models. Post-signal, the tone changed. Keynote speakers began admitting ignorance with refreshing candor. A Nobel laureate's now famous closing remarks captured the mood. For every question this signal answered, it asked 10 more. And that's not failure, that's the point. The scientific method, it turned out, wasn't just about solving puzzles. It was about learning which puzzles were worth solving. Now, years later, the signal's greatest legacy isn't a particular theory or technology. It's the cultural shift it ignited, a renewed willingness to sit with mystery, to chase down anomalies without immediate answers, to prize curiosity over closure. The night sky feels different when you know it might still hold whispers you can't yet comprehend. And that's not terrifying, it's exhilarating, because the alternative, a universe with no more surprises, would be infinitely lonelier. Even as the signal's silence stretches into years, the tools to chase its mystery are growing sharper. The square-kilometer array, slated to go fully operational in the coming decade, isn't just an upgrade, it's a revolution. Spread across 2 continents with thousands of antennas synced in perfect harmony, this behemoth will comb the cosmos with a sensitivity 50 times greater than any existing telescope. Imagine trying to hear a whisper in a hurricane before, and now being handed a microphone that can isolate every raindrop. If that signal, or anything like it, dares to whisper again, we won't just hear it. We'll dissect its every frequency, map its every ripple, and perhaps finally glimpse the hand that crafted it. But the hunt isn't just about scale, it's about strategy. Astronomers have turned the signal's disappearance into a roadmap. Machine learning now scans decades of archival data for anomalies that might have been dismissed as noise, searching for echoes of that original transmission hidden in plain sight. Meanwhile, quantum-enhanced receivers are being tested to detect signals encoded in dimensions beyond our current grasp. Because if the universe's next message isn't in radio waves, we need to be ready to listen in every possible language. The most tantalizing prospect, the signal might not need to repeat for us to find its source. Advanced algorithms now cross-reference its unique fingerprint with gravitational wave detections, neutrino emissions, even dark matter distributions, hunting for cosmic breadcrumbs that could lead us to its origin. It's like reconstructing an entire city from a single dropped key, painstaking, but not impossible. And if the square-kilometer array catches so much as a whisper from that same patch of void, triangulation could pinpoint its home with precision down to a single solar system. Yet for all our technological leaps, the cosmos still holds the upper hand. The signal's greatest lesson might be patience. Ancient light from distant galaxies takes eons to reach us. Some stars we admire tonight died before humans walked the Earth. Why should a conversation spanning light years unfold on human schedules? The telescopes we're building now may not solve the mystery in our lifetimes. But they'll pass the torch sharpened, refined to the next generation of listeners, because the universe rarely shouts, it murmurs, and when it chooses to speak again, we'll be there, ears pressed to the static, ready to catch every word. While the world's top astrophysicists scramble to decode the signal's secrets, an unsung army of amateur astronomers and citizen scientists were already hot on its trail, proving that sometimes the most groundbreaking discoveries aren't made in ivory towers, but in basements and backyards. Online forums lit up within hours of the signal's detection, with hobbyists sharing raw data, homemade visualizations, and wild theories that would have taken months to surface in peer-reviewed journals. One retired engineer in Norway, sifting through publicly available radio telescope feeds, was the first to notice a subtle harmonic pattern buried in the noise, a repeating sequence of prime numbers that had slipped past automated filters. Meanwhile, a high school teacher in Argentina repurposed her classroom's astronomy software to track the signal's drift, uncovering an anomaly in its Doppler shift that suggested it wasn't just moving, it was correcting its course. The real turning point came when a crowdsourced project, dubbed Signal Sleuths, went viral. Thousands of volunteers, from PhD candidates to grandmothers with a knack for puzzles, divided the transmission into microsecond snippets, analyzing each fragment through every lens imaginable. A graphic designer in Seoul converted the pulses into 3D topographical maps, revealing geometric shapes invisible in traditional spectrograms. A music producer in Berlin slowed the signal's waveform to audible frequencies and recognized a cadence eerily similar to error-correcting codes used in digital audio. These weren't just lucky guesses, they were strokes of genius from minds unburdened by academic orthodoxy. The professionals had been looking for extraterrestrial Morse code. The amateurs found something closer to a symphony. What made their contributions so vital wasn't just fresh eyes, it was sheer volume. While institutional researchers were bogged down by bureaucracy and funding cycles, the crowd worked around the clock, fueled by nothing but curiosity. Open-source algorithms shared freely online processed data 100 times faster than some government supercomputers, simply by distributing the workload across tens of thousands of home PCs. A teenager in Mumbai even built an AI model that predicted the signal's next appearance window down to the millisecond, something major observatories had struggled to pin down. The lesson was clear: when you invite the world to solve a puzzle, the world will surprise you. This democratization of discovery reignited an old debate about who gets to explore the cosmos. For centuries, astronomy was a gated community restricted to those with access to expensive telescopes and elite institutions. The signal shattered that hierarchy. Suddenly, a farmer in Kenya could spot a pattern that NASA supercomputers overlooked. A Twitch streamer could live stream his attempts to decode the transmission, drawing crowds larger than some academic conferences. The mystery became a global collaboration, blurring the line between scientist and enthusiast. But the amateur's greatest contribution wasn't technical, it was philosophical. While experts debated whether to reply to the signal, citizen scientists were already crafting messages. School children encoded drawings of Earth's landscapes. Indigenous elders shared traditional star lore in binary. A collective of poets translated verses into mathematical harmonics. Their work posed a provocative question: if humanity ever does send a reply, who gets to speak for Earth? The answer, it seemed, was written in the signal static all along. Exploration doesn't belong to the privileged few. It's a chorus, and every voice matters. The signal didn't just rewrite textbooks, it supercharged entire fields of technology in ways no one saw coming. Decoding those cryptic pulses forced researchers to tear up old playbooks and invent tools that pushed the boundaries of what machines could learn. Artificial intelligence, once limited to recognizing cat photos and optimizing ad clicks, suddenly found itself in the cosmic deep end. Teams at DeepMind and OpenAI repurposed their most advanced neural networks to tackle the signal's fractal-like patterns, training models that could spot subtle repetitions even veteran astronomers had missed. The breakthrough, these AI systems didn't just analyze data, they taught themselves to think in higher dimensions, mapping the signal's structure in ways human brains couldn't conceptualize. One algorithm, originally designed to predict protein folding, accidentally cracked a nested encryption layer in the transmission by treating it like a biological puzzle. The spin-offs rippled far beyond astrophysics. Medical researchers soon adapted these techniques to detect early-stage tumors in MRI scans, finding patterns invisible to the human eye. Data compression underwent its own revolution. The signal's efficiency was humbling. It packed more information into a single pulse than humanity's entire early radio broadcasts combined. Engineers reverse engineering its structure stumbled on encoding methods that slashed file sizes by 80% without losing quality. Streaming platforms quietly adopted the tech, enabling Ultra HD video to reach remote villages with spotty bandwidth. But the real game changer was in deep space communication. NASA and next-gen probes now use signal-inspired protocols to transmit terabytes of planetary data using power equivalent to a light bulb. What began as a hunt for alien messages might end up being the key to our own interstellar ambitions. The parallel to the Apollo program is uncanny. Just as the race to the moon gave us GPS and cordless tools, the scramble to understand the signal birthed innovations no one set out to create. Quantum computing leaped forward when physicists realized the transmission's error correction codes mirrored techniques needed to stabilize qubits. Materials science got a boost from studying how the signal's frequencies resisted cosmic interference, leading to metamaterials that could one day cloak spacecraft from radiation. Even urban planning felt the ripple effects. Fractal-based traffic algorithms, inspired by the signal's nested patterns, now optimize subway flows in megacities from Tokyo to Mexico City. Yet the most profound legacy might be how it reshaped our approach to problem solving. Before the signal, AI was mostly a blunt instrument, good at narrow tasks, terrible at adapting. But wrestling with an enigma that defied categorization forced engineers to build systems that thrived on uncertainty. Today's most advanced neural networks, the ones diagnosing rare diseases or predicting climate tipping points, trace their lineage back to those frantic months of teaching machines to ask, "What don't we know?" The signal didn't just give us new tools, it taught us how to think differently about discovery itself. And perhaps that's the ultimate irony. While we strain to hear a voice from the stars, the universe sent us something else entirely, a mirror reflecting our own potential. The signal's greatest gift wasn't contact, it was proving that the pursuit of the unknown, even without clear answers, can unlock capabilities we never knew we had. Every time a surgeon uses AI to spot a tumor, or a researcher transmits data across continents at the speed of light, they're building on a foundation laid by 72 hours of static that changed everything. The cosmos might still be silent, but its echo is everywhere. The moment that signal crackled through the void, humanity realized something startling. We had no idea how to talk back. No rulebook, no ambassador, not even a basic understanding of cosmic etiquette. It was like receiving a letter in a language you don't speak, stamped with a return address you can't locate, and realizing your reply could trigger anything from enlightenment to extinction. In the years since, the world's top scientists and diplomats have scrambled to draft protocols for the next time the universe rings our phone, because make no mistake, there will be a next time. The United Nations Office for Outer Space Affairs now houses a little-known division called the Post-Detection Task Force. Their mandate: to prevent humanity from blundering into an interstellar incident before we even grasp the rules. The guidelines they've crafted read like a surreal mix of diplomatic handbook and sci-fi survival guide. Rule 1: verify, then verify again. False alarms aren't just embarrassing, they're geopolitically destabilizing. The task force maintains a global network of cross-checking observatories, ensuring no single telescope's glitch gets mistaken for a cosmic hello. Rule 2: no solo replies. The days of rogue nations, or worse, billionaires beaming messages into the dark without consensus, are over. Every proposed transmission must clear an international review panel so humanity speaks with one voice, not a cacophony of competing agendas. But the real challenge isn't technical, it's psychological. The task force's psychologists coined the term signal shock to describe the collective paralysis that follows first contact. Their simulations predict everything from mass religious awakenings to stock market collapses, depending on the message's content. To mitigate chaos, they've pre-written press releases for every scenario, celebratory for a confirmed greeting, cautious for an indecipherable pattern, grim for, well, the possibilities we'd rather not dwell on. Satellite networks stand ready to broadcast simultaneous translations in 60 languages, because in a crisis this profound, misinformation spreads faster than light. Yet for all our preparation, the protocols have glaring blind spots. Take response lag, the agonizing delay between receiving a signal and sending a reply across light years. By the time our message arrives, the senders might have evolved beyond recognition or vanished entirely. Then there's the anthropomorphic trap. Our drafts are steeped in human assumptions, math as a universal language, peaceful intent as a default. But what if the sender's perception of reality is as alien to us as sonar is to sight? One SETI linguist likens it to ants trying to compose an email. The medium itself might be incomprehensible to the recipient. The truth is, no document can truly prepare us. When that next signal comes, all the protocols in the world won't erase the primal awe or terror of realizing we're not the universe's sole authors. The best we can do is ensure that when we finally press send, the message reflects not just our intelligence but our wisdom, because in a cosmos that's just begun to whisper back, first impressions might be the only ones we get. The silence after the signal didn't just feel like an absence, it felt like a held breath. Some researchers now believe those 72 hours of transmission weren't the main event at all. Think of it like a knock on the door. You don't keep knocking if someone answers, you wait. The signal's sudden stop then might not be a disappearance, it could be a pause, a deliberate silence to see what we do next. Consider the timing. The signal didn't vanish mid-cycle or fade into static. It ended cleanly, right after our most aggressive attempts to decode it. Coincidence, maybe, but what if it was designed that way? A civilization advanced enough to beam a message across light years would understand the power of a well-placed silence. It's the oldest trick in the communicator's playbook. You learn more about someone by what they do when you stop talking than when you're filling the air. This theory flips the script on everything we assumed. The signal wasn't the message, our reaction was. Did we panic, collaborate, turn on each other? The answer, scrawled across headlines and lab notebooks alike, was all three. Governments scrambled to control the narrative, scientists formed unprecedented alliances, and the public oscillated between awe and existential dread. If this was a test, we didn't just take it, we broadcast our every strength and flaw in real time. Then there's the chilling alternative. What if we failed to meet some unspoken threshold? Ancient human cultures used trial by ordeal, throw someone in deep water, and if they drown, they were guilty. The signal's silence could be the universe's version of that. A civilization might send out probes not to greet peers, but to weed out those too reckless or divided to trust with cosmic conversation. The fact that we heard anything at all could mean we're on someone's radar. The silence afterward might mean we're no longer worth the energy, but here's the twist that keeps astrophysicists up at night. The most advanced civilizations wouldn't think in years or decades, they'd operate on timescales we can barely grasp. A 72-hour transmission followed by years of quiet might not be a snub. It could be the equivalent of leaving a voicemail and patiently waiting centuries for a callback. After all, if you're immortal, what's a few generations of silence? The real message might still be coming. We just haven't waited long enough to hear it. The unsettling truth, we're like ants analyzing a satellite image. Even our smartest theories might miss the point entirely. The signal's brevity, its silence, even its mathematical beauty, they could all be red herrings. The only thing we know for certain is that the universe has a way of humbling our assumptions, and right now, it's doing so without saying a word. In the years following the signal's disappearance, astronomers began noticing something peculiar, not in the empty void where the transmission had originated, but buried in decades-old data. Deep within the grainy static of vintage radio telescope recordings, faint anomalies flickered like half-remembered dreams. At first dismissed as equipment noise or cosmic interference, these echoes gained new significance in the signal's shadow. One particularly haunting example emerged from a 1982 survey of the Andromeda Galaxy, where a graduate student at the University of Manchester uncovered a burst of radiation that precisely matched the harmonic signature of the modern signal, just 40 times weaker. The odds of such a match being random, less than 1 in a billion. Then came the real shocker. When researchers applied advanced machine learning to sift through petabytes of archival observations, they found dozens of similar blips, each isolated, each brief, but all sharing that same unnerving mathematical fingerprint. Some dated back to the early days of radio astronomy, lurking in paper records that had to be manually digitized. One particularly compelling candidate even appeared in a notebook from Nikola Tesla's Colorado Springs experiments in 1899, where he described intercepting rhythmic cosmic disturbances that defied explanation. The implications were staggering. Either this signal had been brushing past Earth for over a century, going unnoticed until we developed the tools to recognize it, or we'd stumbled onto something far stranger. The debate over these echoes split the scientific community into warring camps. One faction argued they were proof of a much older, much broader phenomenon, perhaps a natural cosmic process we'd barely begun to understand. They pointed to pulsars, those celestial lighthouses, which were initially mistaken for alien signals before their true nature was uncovered. But the dissenters countered with a chilling observation. The archival signals weren't just similar. They were evolving. Early examples were crude, fragmented, like a child's first attempts at writing. By the time the 2023 transmission arrived, the structure had refined into something unnervingly precise. Nature doesn't iterate, intelligence does. Then there were the gaps, those long stretches of silence between echoes, plot them on a timeline, and an eerie pattern emerged. The intervals weren't random. They followed a rough Fibonacci sequence, each silence longer than the last, as if whatever was transmitting was pacing itself or learning patience. The most unsettling theory came from a team at the SETI Institute who suggested these weren't failed attempts at contact, but tests progressively complex messages sent at intervals designed to gauge when we'd finally be listening closely enough to hear. Amid the frenzy, a sobering truth took hold. The universe might be full of whispers we've been too primitive to notice. Like ants oblivious to radio waves, we could be swimming in signals just beyond our perceptual reach. Those faint echoes in the archives weren't just curiosities. They were breadcrumbs hinting at a conversation that's been unfolding for millennia. The real question isn't whether the signal will return. It's how many others we've missed. Humanity's reaction to the signal wasn't just a response, it was a Rorschach test for the species. Peel back the layers of scientific analysis, the frantic government meetings, the breathless media coverage, and you'll find something raw and revealing. The signal didn't introduce us to aliens. It introduced us to ourselves. The moment those pulses hit Earth's telescopes, civilization split into 1,000 reflections, each revealing a different facet of who we are when faced with the unknown. Take the scientists first. These were men and women who'd spent careers chasing cold, empirical truths, only to find themselves suddenly cast as detectives in a cosmic whodunit. Some doubled down on skepticism, dismissing the signal as a fluke of astrophysics, their caution a shield against paradigm-shattering change. Others, though, let their imaginations run wild, drafting papers that read like interstellar fan fiction. The same rigor that once kept wild theories in check now fueled them, proving even the most disciplined minds aren't immune to wonder, the real revelation. How quickly the line between serious researcher and starry-eyed dreamer blurred when the data defied explanation. Then there were the politicians. Watching world leaders scramble to address the signal was like witnessing a global identity crisis. Hardline nationalists softened their rhetoric overnight, suddenly emphasizing planetary unity, right up until classified briefings suggested the signal might contain proprietary decryption challenges. That's when the old instincts resurfaced. Patent offices were flooded with preemptive claims on hypothetical alien tech. Space agencies quietly shifted satellites into defensive formations. The juxtaposition was almost comical. Public speeches full of starry-eyed optimism, while behind closed doors, generals war gamed first contact as if it were an invasion scenario. Humanity's best and worst impulses laid bare by a few hours of static, but the most telling reactions came from everyday people. Walk into any cafe in the weeks after the signal's discovery, and you'd hear conversations that would have been unthinkable a month earlier. Barristers debated xenolinguistics, construction workers quoted Drake equation variables. For a fleeting moment, the world felt like a college dorm at 2 a.m., alive with big questions, unafraid of sounding naive. Social media, usually a battleground of petty divides, became a makeshift agora where strangers collaborated on crowd-sourced decryption attempts. The signal did what no pandemic, no war, no climate disaster had managed. It made Earth feel small in a way that united rather than terrified. Yet beneath this surface unity lurked darker currents. Survivalists stockpiled ammunition, convinced the signal was a predator's lure. Doomsday cults declared the transmission a cosmic, delete command for humanity. Even among the hopeful, there was an undercurrent of existential vertigo, the uneasy sense that we might be mid-tier intellects in a galactic hierarchy we barely comprehend. Psychologists coined the term cosmic imposter syndrome to describe the phenomenon, high-achieving individuals suddenly questioning whether their life's work would seem trivial to a civilization capable of engineering such a signal. The most profound impact wasn't on our technology or politics, but on our collective psyche. What's fascinating is how quickly the signal became a canvas for our existing fears and hopes. Conspiracy theorists heard confirmation of government cover-ups, religious leaders discerned divine fingerprints, tech billionaires saw a user manual for the next leap in evolution. Each interpretation said less about the signal's content and more about the lenses through which we view the universe. The transmission could have been a grocery list encoded in pi, and we still would have projected our deepest anxieties and aspirations onto it. Now, years later, the signal's greatest legacy isn't in any scientific breakthrough it spurred. It's in the mirror it held up to a species that rarely pauses to examine itself. The transmission forced us to confront uncomfortable truths, that our curiosity is matched only by our capacity for fear, that our hunger for connection wars constantly with our instinct for control, and that for all our telescopes and algorithms, we still don't know what kind of civilization we want to be when no one's watching. The silence that followed wasn't just an absence of sound. It was an invitation to keep listening, yes, but also to decide what we'll say when we finally find the courage to whisper back. The day deep space echoed a signal that shouldn't exist remains one of science's most tantalizing puzzles, a cosmic whisper that redefined what we thought possible. Whether it was the product of some exotic celestial phenomenon we've yet to understand or the first faint murmur of intelligence beyond our own, its legacy is undeniable. It didn't just crackle through our telescopes, it tore through the boundaries of human imagination, forcing us to confront a universe far stranger, far richer than our textbooks had ever dared to suggest. Think about how much has changed since that moment. Before the signal, the search for extraterrestrial intelligence was a fringe pursuit, relegated to late-night documentaries and hopeful speculation. Now it's a cornerstone of modern astrophysics, with billion-dollar telescopes and international collaborations dedicated to scanning the void for another whisper. Before the signal, we assumed we'd recognize alien communication as something dramatic, a flashing beacon, a mathematical broadcast. Now we know the truth might be subtler, hiding in patterns so complex they defy our current tools. The signal didn't just expand our sense of the possible, it humbled us with the realization of how much we still don't know. Yet for all its mystery, the signal gifted us something profound, a renewed sense of wonder. In a world where so much feels mapped and measured, it reminded us that the cosmos still holds secrets waiting to unravel. Every time a new telescope peers into the dark, every time a grad student sifts through static for anomalies, they're standing on the shoulders of those 72 electrifying hours when the universe proved it could still surprise us. So where does that leave us? Not with answers, but with something just as valuable: questions. The signal's silence isn't an ending, it's an invitation. An invitation to listen more closely, to question more deeply, and to stay open to the possibility that the next great discovery might be lurking in the next burst of static, the next blip on a screen. Because if history has taught us anything, it's that breakthroughs rarely come when we're looking for them. They arrive when we're looking past what we think we know. As you step outside tonight and glance up at the stars, remember, the cosmos isn't just a backdrop, it's a conversation. And somewhere out there, in the vast, whispering dark, the next signal might already be on its way, ready to shatter our assumptions all over again. Stay curious, stay skeptical, but most of all, stay listening. The universe has a way of speaking when we least expect it.